Hello friends, welcome back to K8s YouTube channel. This is the episode 8 of Kubernetes 0 to Hero series. Okay, so here in today's video we are going to discuss about the Kubernetes controller, what are the controllers basically Kubernetes has, and here we will go deeper inside the deployment and StatefulSet controller. Okay, because these are the two main controller which is mostly used in Kubernetes. Okay, so here we will discuss these both deployment and stateful concepts practically by deploying the Mongo database, okay, which is basically a stateful application. Okay, we will also add it with the Mongo Express, which is the basically stateless application. It means it can independently scale. So here we will also implement the HPA, which will automatically scale well based on the CPU and memory matrix. Okay, so here what will be we are going to cover, we are going to cover StatefulSet by using Mongo database. Okay, and deployments for Mongo Express, that is the basically a front end, or you can say the user oriented, user first module. Okay, so services, here we are going to use the node port and headless services. Okay, and storage concepts, here we will as in my previous episode I already discussed the what are the various types of storage in detail. So if you don't know, then you can go back there. Okay, here we will discuss the PVC and storage class mainly. Here we will locally set up it by using the rancher. Okay, so scaling, here we will use the HPA based on CPU and memory matrix. Okay, what is HPA? HPA is basically horizontal port auto scaler. Okay, so we will see all together in action how these all together work. So before going into deep, let's discuss the basic concepts of Kubernetes controller. So I also told about this, what are the controllers in my introduction video. So it's basically a controller continuously check the desired state. Okay, from where it check, from the control planes to node. Okay, so desired state by IML specification versus actual state. Okay, so it continuously checking, it means it's continuously running in loop. Okay, to match the desired state and to the actual state. Okay, and it's make the changes. Okay, it means its main objective is to match the desired state with the actual state. Okay, so here mainly three, when we know about this, then there are mainly three types of controllers, that is deployment, statefulset and daemon set. Okay, so here the deployment is mostly used by the stateless applications, and statefulset will be used by the stateful applications, and daemon set we cannot manage manually, it's managed by the Kubernetes controller itself. Okay, so it's basically a per node service which basically run on every node. Okay, so like if you take the example of deployment here, then it's basically, as you know, it's used by the web apps APIs. Okay, and statefulsets are mainly used by the databases. Okay, it can be also used by the Kafka and other messaging tools that require the statefulness. And daemon set, as you know, we cannot manage that, but it's what it manages. It manages basically logging and monitoring. Okay, behind the scene, it's this is the main unit of the controller agent. You can think like that. It's running on our nodes. What is checking? It's checking log, monitoring and states. Okay, so here when we have to implement the statefulset, then we will require the persistent volume, PVC and storage class. Okay, and the replica sets are basically internal to pod scaling layer. Okay, and two other types of controllers also Kubernetes has, that is the job, that is basically used for the, if you have to run any job once, then we use the job. If you have to run on some schedule basis or recurring jobs, then we will use the cron jobs. Okay, so we will cover these two in detail in another video, how we can utilize these jobs and cron job, okay, to schedule the daily administration or maintenance jobs, okay, that might require the manual intervention. Okay, so here our main focus will be the on stateful set and deployment. So what is the core difference between these? Okay, so deployment is used for stateless application, like here pods are interchangeable, but in stateful set it's used for stateful applications and each pod has a unique identity and storage. Okay, and deployment has random pod names. Okay, like in this manner, you already know that we mainly use the deployment till now. And stateful sets have fixed and predictable names so that it can bind with the correct storage, correct pods. Correct pod can bind with the exact storage. And identity and persistent across restart. Okay, so it's basically protect that. Okay, and storage, at point of storage, basically deployment has shared or ephemeral storage mostly, and data may be lost when pod is deleted. But in stateful set, each pod gets its own persistent volume. Data stays even if pod restarts. Okay, if pod will restart, then again it will take the same name and it will attach with the same volume. Okay, so what is the difference between scaling behavior? So it's basically in deployment it can scale randomly, pods created, deleted in order, okay, in any order. And stateful set it's basically scale in order, like if create will happen, then first it will create 0, then 1, then 2, then 3, then 4, then so on. And if we have to delete the stateful set, then stateful set pod will be deleted in order also. Basically order will be the last in first out. It means it lost this pod number 2 is created, then it will first deleted here. Okay, and at networking deployment, pod gets dynamic IP, no stable host name, but stateful set uses each pod gets stable DNS name because it uses the headless services. Okay, so use cases we already discussed. Deployment is mainly used for the web applications, React, Node.js, APIs or UI heavy applications. Okay, that can scale independently, like for microservices, stateless backends. But stateful set is used when we have to use it with the databases or distributed system like Kafka, Elasticsearch, like things. Apps, basically the application that require the persistent identity or storage. Okay, so here if we quickly compare the feature, then deployment is we already cover all this. So app type here will be like stateless, and in stateful set we will use the stateful application type. Pod identity in deployment it can be random, but in stateful set it should be stable. It always be stable. And storage here is temporary or shared, but here it will be persistent for pod. And scaling is unordered, but here scaling will be happen in ordered manner. Okay, and networking here it's basically follow the dynamic networking, but here it's get stable DNS. Okay, so here like if we go deeper about stateful sets. So a stateful set is a Kubernetes controller used to manage stateful application apps that need stable network identity, persistent storage, order deployment and scaling. Okay, so features we already discussed. Okay, so let's discuss the concept of HPA. Okay, so basically HPA is horizontal pod autoscaler. HPA automatically scales pod based on metrics like CPU usage, memory usage or custom metrics. Here we will also implement the HPA in this same video, and we will basically scale our application. Okay, so that will be the Mongo Express. So how it works, basically it monitor metrics by the metrics server. We will also implement the metrics server here. Okay, and it adjusts the replica count dynamically that will specify in our deployment. Basically, it's ideal for scaling the, here in our case it's will scale the Mongo Express application, that is UI component only. It's basically not ideal for the Mongo database itself, that is in StatefulSet in nature, because scaling that will require the multiple other things that should be in place, otherwise we are not able to scale that properly. So it's required the basically replica set reconfiguration, data synchronization, HPA just remove basically HPA just remove or add spot blindly. So extra configuration will be required, that we will see in upcoming videos. Okay, so better approach here will be, if we have a stateful set, then we can manually scale those applications, okay, without using HPA. Or if we have to configure HPA, then we have to take the multiple measures. So here we already discussed what are the PBs. PB basically a persistent volume, is a piece of storage in Kubernetes. Characteristics include independent of pod lifecycle, can be used after pod restart, backed by the local disk or cloud storage or physical storage that we can implement with the CSI that I already discussed in my last video. Okay, so PBC is just a request for storage by a pod. You can think like PB is the actual disk, PBC is a request or claim for a disk in StatefulSet. Okay, so each replica gets its own PBC, like MongoDB 0 will get the PBC, MongoDB 0 and MongoDB 1 will get PBC, MongoDB 1, MongoDB 2, PBC, MongoDB 2. Okay, so if anyone the pod get down, then next pod will create with the same name and the same storage will be binded back with the that pod. Okay, so what is the storage class? Storage class define how storage is dynamically created by its method, because it's basically facilitate the automatic provisioning of the storage. Okay, here we can provision SSD, STD, AWS, GCP local or local storage, or in enterprise we can just integrate with the CSI, basically container from the container storage interface provisioners. Okay, so here we will here we are going to discuss also the node port. We are going to use the node port services that I already explained basically how it works. It's open a port and every node, okay, like 3007 port will be open and binded back with this our services. Okay, so it's basically a service type that will bind the a simple port with the every node that we can access, but in enterprise it's mostly avoided. Okay, so here, but in our lab we will use this. So if we put all together, then here we will create a stateful set. MongoDB, it creates basically port with predictable name. Okay, each port gets a PBC, storage class provision PBC, data persistent across restart. We will also test it. Okay, and node port exposes the Mongo Express UI. Here we will implement the HPA, horizontal pod autoscaler, and we will also test the by giving the load on that. Okay, so here we will also use the headless services, okay, for giving a predictable DNS name to our stateful set applications. Okay, so without wasting time, let's start with our lab. Also, one more thing, here we will require the ranchers for provisioning the local storage. So you can just Google it on like ranchers local provisioner, and you can just get a link. You can have to implement that. Okay, so you can just simply either you can just copy this, okay, and apply by providing the link, GitHub link. Okay, just copy this, and here let's start with our practical session. So that's it. So just I already had applied. Okay, yes, let me okay, I will require the exact YAML file, not the git file. So just go here and you can just copy this, okay, or from here you can get a link okay, or you can simply download this file. So basically what it will create, it's basically provision a local path on every node, okay, and here by using the storage class we will simply able to claim this. You can get this file, okay, and you can also reconfigure it as per your requirement, okay. So I have already downloaded this, okay, and applied that. So let's continue with our practical. Okay, so here first we will like after applying this file that I have already applied, okay, so let me show you. Here this is the my directory StatefulSet application. So here we have components.ml here for provisioning the basically matrix server, okay. So here let me show you. Okay, so here I have used these YAML files. Let me explain you. First of all, it's for the components.yaml that will implement the what? It will implement the matrix server here. Okay, so here you can see that API version v1, and here it says multiple YAML file in a single components.yaml file. Okay, so here it's implementing many things. Okay, so like here it's implementing service account, cluster roles, API groups, all these things. You can go through with that I also downloaded. Okay, so you can also download this and you can apply this first of all. Okay, so here let me show you. You can just simply apply kubectl apply -f. All these files are present in my git repo. Okay, so you can go there. So here, so it's basically deployed the API basically matrix server here. Okay, so it's saying matrix server created. Okay, so fine, our matrix server is currently working fine. Okay, so after that what we will require that here, why we will require the matrix server, because we are going to use the HPA also. Okay, so that's why. So and then what we will do, the second part is we will require the storage. Okay, so for that we have to define somewhere in storage class. Okay, so let's go below. Okay, so here is our it's a local path provisioner. Okay, so here ls. So for local path provisioner we have also this YAML file for provisioning that. So here we can see that it's basically name is local path storage. It's basically get storage from the every node, okay, on which we are going to schedule our pods. Okay, so what it will do, it will basically get list, watch, create, patch, update, delete. All things will happen by using this local path provisioner itself. Okay, so that I have already put the link in GitHub. Okay, my GitHub link is already visible to you too. So it's listed there. You can use the same for provisioning the local path. Although if you have if you are going to implement the PPG in different form, then we will not require this. Okay, so and here, so we will require this, and then we have to define the first of all Mongo stateful YAML. Okay, first for that we will first define the stateless.yaml that we are first use in our basically Mongo stateful specification. Okay, so I have already done that stateless.yaml, because it will, if I will do all the things here right manually, then it will take multiple times. Okay, so here you can see that API version is v1, kind is secret, and metadata defined is name MongoDB secret, and type is open, and data here is in data section. You can see that Mongo root username is this, that is basically Mongo admin, and Mongo root password is this is the base 64 encoded. Okay, so also if you have to secure one more layer, then we have to use the third-party vaults for that, like you can use the HashiCorp vault, okay, to encrypt this secret inside the vault. Otherwise, any user can able to see this encoded passwords, okay, or secrets, just by running the base 64 command. Okay, because it's just a base 64 encoded, not the encrypted. Okay, so then after defining this, we will just create the first of all Mongo stateful deployment, stateful set. Okay, so let's go. This is the important one for our perspective, although everything is important, because if one of our complete stack can fail with the just a simple if we will do give one more extra space. Okay, so here you can see that API version is v1, kind is service, metadata name is Mongo, database internal, labels we have defined the MongoDB. Okay, basically what are the, this is the most important thing, labels. By using the labels, we basically expose in Kubernetes all the things like will match by using the labels and selectors. So it's a very important parameter, you have to remember that, and you have to give the predictable and simple name to your labels. Okay, specification, here we are going to expose it on port 27017. Here we has already defined the, this is the state headless services. Why we are using headless services here? Because we want a predictable DNS name. We don't require any VIP. Okay, so that's why here cluster IP is set to none. When we set the cluster IP is cluster IP none, then it will basically assume that it's a headless service and it uses the DNS behind the scene. Okay, so now how ports will how our Kubernetes API will basically communicate from our services ports, basically by using the DNS. Okay, unique DNS. So here in selector we have defined the MongoDB. Okay, so this is all for our headless service. Okay, that I already told you, we will use the headless service for implementing the predictable DNS in our stateful set. Okay, so now here our stateful set will start from here. Okay, so it say that this is the document separator in YAML. Okay, it means you can also create a separate document from this to this, but to avoid the complexity, because it's a completely very complex, it's a type of project. Okay, so I have defined all in single document. Okay, single stateful specification. Okay, so here it's a kind of stateful set, and here our MongoDB will be basically deployed. Okay, so specification, here is service name is MongoDB internal. Okay, here you can see that from the headless service it's matching the name. Okay, MongoDB internal. Okay, to expose and match it with, to communicate it with. Okay, so replica, here we are going to use the 3 replica, and selector match label is the app MongoDB. That labels we already told you. Here we are going to use the MongoDB app label. Okay, So template, inside the template we have defined the metadata like labels, same MongoDB specification. Here we have defined some affinity rules, and here our import into affinity like every node so the schedule at least one of the our pod, because here in my lab I have 3 master nodes and 3 data plane also, 3 control node and 3 worker node on the same nodes, because I have untented all those nodes, okay, so that I can schedule the work and also those nodes can work as a worker nodes at the same time as a master node too. Okay, so here we are just we are following the topology of Kubernetes io./hostname. It means it will schedule our pods on the behalf of unique host names. Okay, and container, here we are using the Docker image, basically Docker registry image, that is the Mongo latest. Okay, and its name will be the MongoDB. And here init some environment variable I have specified for that to start, like name is Mongo initdb root username, from where it will basically it will take reference from the, like here we have defined values from secret key reference, and secret key reference, it means we are calling to a secret, okay, that we earlier defined, that I already showed you. Okay, from there it's basically calling to name MongoDB secret and the key Mongo root username, okay, and name Mongo initdb root password. Okay, it's basically taking the secret from, it's again the same secret file, okay, MongoDB secret, and key is Mongo root password. When I will show you that exactly the same name and key will be defined there. Okay, so just we are referencing here to use that secret. Okay, so we can just store the secrets in the, like by providing role-based access control, so that those secrets will be not accessible to every user. Okay, but here the this StatefulSet specification will able to call that, okay, by providing these secret key reference. Okay, similarly all these are here we are just exposing the container port 27017 and name MongoDB, like here where our service will listen on this port that we have set it on the headless services itself. Okay, and the mount path will be like volume mounts will be, name will be Mongo data. Okay, and mount path will be the DataDB. Okay, okay, so here volume claim template is here. Okay, so from here it will claim the volumes by from our local provisioners, okay, that I have already implemented by the ranchers, and the extra YAML file for provisioning the storage class. Okay, so basically on storage class name we are going to use the local path. Okay, it's basically we are going to use the our existing local path provisioners. Okay, otherwise here you can, if you have another storage class name defined, then you can recall that. So for that you have to be extra storage. Okay, so here I am showing this in my lab environment, so it's always best for me to use the local path. If you are also going to use in your home lab, then you can use the same local path. Okay, so all the YAML files I have already pasted in GitHub repo, so you can go there and copy and paste and test there by changing the parameter. Okay, so here our access in specification of volume claim template is specification, access mode is read write once, that is very you can see that the required feature, like based on your requirement you can change it with like read write many, like if you have NFS based storage or shape based storage and your application has requirement of that, then you can use that. But for MongoDB workloads or multiple DB workload, that will be the get storage either from the NVMe or storage or CSI based provisioners. Okay, so that in that case we are mostly going to use the read write ones. Okay, and storage class name as per your requirement. or as per your case you can choose that or change that. Here I am going to use the local path because I have configured the rancher for that, and I have defined the storage class name there. Okay, that is the local path. And here I have resources where we are requesting the storage 2 gigabit, okay, for each. So let's I will also let's go with that, like it's completed for the MongoDB section, okay, but we have to expose this. We have to access it by using the Mongo Express UI tool, okay. So there I will also implement the HPA. So let's go into detail of Mongo Express YAML file. Okay, so what it's basically doing, okay, so here from here it started. So here we are also using the node port services to basically mapping it with the port 33001 that will be accessible from our external places or from our browser. Okay, basically it's exposed publicly. Okay, so node port, what basically node port will do, node port will bind a port on every node, bind this port 3001 from which basically our user faced port. Okay, it basically binded the port 8081 that we exposed inside our services, like for StatefulSet. In StatefulSet for MongoDB we have exposed that. Okay, so it will listen from there. Okay, so here is basically API version, kind is StatefulSet, object type is basically StatefulSet, metadata is Mongo Express. Here we are going to use specification, service name is Mongo Express, spec.replica. Here we have get one replica, but here we will going to use the HPA also. One is enough for our basic configuration. Okay, so labels will be the Mongo Express, specification for the container. Here I have given the Mongo Express latest, and the container port 8081 will be exposed for this, and the environment variable. So here I am using me config MongoDB admin username. Value, we are taking the value from the secret itself, that is the MongoDB secret, and key is Mongo root username that we have already defined in the secret. Okay, so in the same manner we are taking here also. Okay, so here this is the very important parameter. Here we are configuring the MongoDB URL, and here we are supplying the value MongoDB : // Mongo admin password 123 MongoDB internal 27017. Okay, so this is the very important one. So here we are matching the exactly, okay, accessing the URL internally. Okay, so this Mongo Express will access our node, sorry, our MongoDB and this URL, okay, with this credential internally. Okay, this access will happen internally. Okay, here that access will basically exposing the node port to the public. Okay, so client basically can access by using this node port once our all things are working fine. Okay, so let's deploy one by one. First we will let's deploy the secrets.yml. So kubectl deploy -f secrets.yml. Sorry. Apply. Okay, so basically are saying secrets MongoDB secrets created. Okay, so here we have to also configure this local path storage.ml. so here let me show you. It's a very actually complicated one. Okay, so its config start from here. It says name is basically local path storage. You can see that it's also made from the multiple documents. Okay, here we have defined the roles binding, okay, and cluster role binding and deployments. Okay, so here deployment is start for the storage class. So basically saying name is local path storage, replica is 1, selector, match labels, local path provisioners, local path provisioner, service name, service account name. We are going to use the local path provisioner, service account, and the containers. Here we are going to use the rancher image for that. Okay, local path provisioner, this, and image pool policy if not present. Here we will use the local path provisioner, debug, start, config, and volume mounts. So here it's basically uses the name config volume, mount path will be the etc config. It's basically a configuration file that will mount our volume automatically. Okay, so these are all the things. Okay, so here the most important thing one is the storage class for you. Okay, so here you can see that here storage class is defined, and the name is local path that we have referenced in our basically stateful file. Okay, so this is basically taking from here, and provisioner is obviously it's rancher.io local path provisioner that I already told you. We will use that. You can just pull the image here from this is the configuration information. We have to also pull the image for that first. Okay, so this is the things. So every step is important and every space is also important here. Okay, so that's why I have already copy and pasted all these things in my GitHub and also here in advance, because it's not possible to write pre-code here, because if you want to write manually to show you, then it will take a days to write and deploy successfully, because eventually human can make mistakes. Okay, so what I will do, let me show you. All these are the important files. Let me show you one of the most important thing. One is the HPA, which is the horizontal part autoscaler.ml. Okay, so this is the very simple autoscaler which uses the basically CPU and memory to autoscale that there is no custom matrix has been used. Okay, so here just we are going to use the API version autoscaling version 2. Kind is horizontal powered autoscaler. Its object type is horizontal powered autoscaler. Metadata name is Mongo Express HPA, and specification scale target reference is API version F v1. Kind is StatefulSet, and name is Mongo Express. Okay, so here we have given the scale target reference. You have to remember that specification. So we have to spec dot scalar target reference to use the HPA. Okay, so here we are targeting to this F version 1 StatefulSet, which kind is StatefulSet, name is Mongo Express. Okay, that taking from where? It's taking from the Mongo Express.ml. Okay, because here we are going to scale apply this HPA Mongo Express. Okay, here we have defined minimum replica is equal to 1. It means it will in most of the cases when scaling is not required, then here it will maintain the minimum replica 1. But when eventually when we will increase the load, either it's based on CPU or memory, it will increase the replica. We'll also see how you can just get it, put this more stress here. Here we will use the stress image. Okay, to create the extra load here. We will live see how we can scale that. Okay, so resources, here you can see that matrix type is resources, resource, and resource is in first case it's the resource name is CPU. It means we are going to scale based on the CPU, and target type is the utilization. It means when our utilization, average utilization crosses the 50. Okay, it means when any of the pod in this target will have more than 50% CPU load, then it will start scaling. Also similarly, when memory utilization will be greater than 70%, then it will basically start scaling up. Okay, and here we have it's have default cooldown period of 5 minutes. Okay, so once our load will decrease from less than 70 to less than 70%, then it will trigger the cooldown period. Okay, and cooldown period which usually it's set to 5 minutes. After that only the scale down process will start. Okay, although scale up will start immediately when its RAM crosses the 70%, RAM utilization crosses the 70%, and CPU utilization crosses the 50%. Okay, so without wasting time, let's start. Okay, so I will go cd.ls here. Okay, kubectl apply -f and StatefulSet lab. Okay, so it's basically created. Let me see the kubectl. First one is the pvs, so get pv. Okay, so all these pvs are here. Okay, so this is our pv. Okay, so that is percent. Let me see one more time. List terminating bound. Okay, so here these all are the pvs. That is basically here in pv storage claim options access mode, we have defined the read write once only. These are our previous pvds that I already used in my previous lab. Okay, so this is for the here for the current one. Okay, so why it's showing time old, because I have created it's like in morning I have repeated the lab. Okay, so kubectl get pvc. Okay, so here we have all these defined physical volume claims or persistent volume claims. Okay, currently it's bounded, it means it's attached. Okay, it can attach with the only with the pod name that it will have the same name. Okay, so now kubectl get sbc. Okay, so here you can see that we have MongoDB Express. First one is the Kubernetes cluster IP, that is that we don't have to think about that. Okay, that is not part of our lab. Here also Nginx internal behavior is not part of our current lab. Okay, so these are the three things that we have to focus on it. Here we have Mongo Express services, that is basically using the node port service. It's binding the every node with the 30001 port. Okay, every nodes 8081 port with the 3001. So what user can access by providing the IP address of the nodes and by using this port. Okay, so I will show that practically here by accessing that. And here also MongoDB internal cluster IP is there. Basically this is for our headless service. Okay, so this is our headless service that is basically communicating on 27017 port, and it's the MongoDB service. Okay, so that has cluster IP this. Okay, that is also communicating on 27017. So here these two are the communicating. One is the headless service to provide the predictive DNS name to every pod that is in our cluster, so that our this MongoDB service can communicate from each one. And this is the MongoDB Express node port service that is basically exposing to the outer world, you can say that. Okay, so here service section I think you have clear, physical volume section clear, persistent volume section clear, and service section clear. And then after what will come picture? Pods. So here let's kubectl get pods hyphen wide. Okay, so here you can see that these four. So these are the MongoDB 0, MongoDB 1, MongoDB 2. So when we describe the single pod, let me describe this pod. kubectl describe pod and pod name. Okay, so here let me show you all the details. So its name is MongoDB namespace, as obviously we have not specified any other namespace, so it's created in default namespace. We have not specified any priority. Service account we are using the default. Okay, labels we are using app MongoDB, and this Kubernetes IO pod index 0. Okay, annotation we are not using any annotation. Currently it's running. Pod IP is 10.2.4.4.0.26. How it's getting this IP I already discussed in my networking videos. So if you don't if you have not seen that my networking video, then go and see. I have covered in deep how pods get IP addresses basically there. Okay, and how they communicate from each other. So container ID is this, image is this, port is 27017. It means this port is being exposed by this pod, and we are using the environment variable. It's basically secrets. Okay, here we are also mounting inside DataDB in read write mode. Okay, condition initialize true, ready to, container ready to, pod scheduled. So here when we comes in volume section, here you can see that Mongo data type is persistent volume claim, a reference to a persistent volume claim in the same namespace. Claim name is Mongo data MongoDB 0. Okay, so it's basically claim to MongoDB 0, that's why, and claim will be successfully granted, that's why it's currently running. Okay, here it's scheduled, pulled, created and started the container MongoDB. Okay, so you can see that it's always basically claim the predictable names also map with the same. So let me one time I will show you this code. kubectl get pods hyphen o wide. Okay, so here every first of things we have applied the affinity rule here. So what you can see that I have 3 nodes, all are working as a control plane, at the same time also working as a data plane or worker node. Okay, so here you can see that each of the MongoDB 0 is scheduled on node 1, MongoDB 1 is scheduled on node 2, MongoDB 2 is scheduled on node 3. So it's very important to write the correct affinity rule to maintain the high availability. Okay, so what will happen if any of the my node will get down, then it will not affect to our either to my master, or you can say to control plane, also to our workers or the pods. Okay, because complete high availability will be maintained in that case. So I can show you in live manner. Okay, so when I will stop the node 3, our this services will still work fine. Okay, so let get access the services. So it's basically exposing on 3001. So I am accessing on this localhost port, although I can use any of the node IP. So here, so when I will go here, get nodes -o wide to get the IP addresses of this. So let me take the IP address of 218. Okay, so I will come here, paste the IP address this. Okay, enter. So it's basically asking for the password. Okay, but service is currently working here, so if it's asking password, then just you have to, there is a default password for accessing the Mongo Express. So if you don't know what password you have to enter, I also enter the correct one. Just I am forgetting the name, so I will search the name here also. If I will use the this, okay, let me use it's just a default name something, or let me search. Okay, default username and password for Mongo Express UI first access. Okay, so it's a admin and pass, so you can provide the same. Okay, so you can use the any of the node when we are using the okay, so here we are able to log in that. Okay, so here you can see that we are inside the our, you can, although you can use the any of the node name. Okay, so here let's create a database, and database name is, let's, I am giving the StatefulDB. So it will create the database, and when we will go inside that, so here we can create a collection, like name, collection name will be like users. Here we are want to store the users related record, so here we can create a new document. So for creating new document, there are the multiple formats, so you can just search it on Google. Okay, so or you can use the ChatGPT like tools to create a simple record. So it means my complete Mongo database is working fine. Okay, I want to create record. So here document record of users, provide me the details of 3 or 10 sample users are same, and here we will take the JSON. Okay, so it will provide us, so it's basically a DB related task. Okay, so you can use these tools also, because MongoDB is the non-relational database. Okay, so here just click on save. MongoDB some field insert document 0 wrong type and expected type object. Okay, it means ChatGPT response was not completed. Okay, think something happening behind the scene. Connection server 2. Okay, so let me check is all is well or not. Of course it's ready. kubectl get pod. Okay, so basically load search increased by. Okay, so here you can see that our horizontal pod scaler is in action. Okay, it's scaling. Let me delete ctl delete pod memory stress fin now. Okay, so let me check. Let me use the local host because this is the most safe. Okay, why I prefer to use local host? Because this my laptop I have 3 nodes, you can see that. Okay, and node 1 is the actual my machine. Okay, node 2, node 3 are the VMs that have only 4 GB of RAM. So for running the multiple pods also there is not the preferred way. But although my node 1 has, you can see that I have the plenty of resources in my node 1. Okay, so I will prefer to use the node 1. So localhost here, if we are accessing from here, then it means I am accessing from node 1. Instead of localhost, I can provide the IP address of my node 2. Okay, here I can provide this IP address to. Okay, so to access this 192, sorry. Okay, so here it's also you can provide the same ID and password and access this by using this IP, but I will prefer to use localhost because I have already authenticated that and I have session for that. Okay, so here SourceDB is here. I saying database not found. Let me create the database. SourceDB. Create database. Go in SourceDB. Let's create a name, users. Okay, wait. kubectl get HPA. Currently 2 replica sets are here. Okay. kubectl delete HPA. Okay, so I guess why, because we have not applied the sticky sessions here, and it's basically when we have 2 replicas behind the scene of the same UI, it's basically request is transmitting once to this DB and once to another database. Okay, so that's why we are we are facing that problem. Okay, here you can see that right now we are not here currently, no SauravDB is here, but here you can see that when request is here, I am refreshing, SauravDB is here. Okay, refreshing, it's not here, refreshing, it's not here, refreshing. Okay, so now it has inconsistent state. Okay, so we have to also, when we are implementing HPA, then we have to also take care of the sticky sessions. This is the very good lessons for you. Okay, so here I have just deleted the HPA. Okay, so now when I will show you kubectl get pods. So here currently I have the Mongo Express. Okay, so 2 replicas are running, but right now it's not routing with the LBA. Okay, so let me also delete from here to be consistent. Mongo Express delete pod pod name. Okay, so right now it will come into most consistent state. Okay, so here we can create the database name like in this manner. Okay, so why that was happening? Because we have not applied the sticky session and request was going to the different replica. Okay, so we have 3 replicas. Okay, so load balancer was just routing the traffic once to this replica, then after to that replica, then to that replica. That's why. So now we will not get that problem. Okay, so now let me create a users collection here. Create collection. Here we can create a new document. In JSON. So come here, save. Okay, so here you can see that it's saved. Name ID is this, name is this, email, phone. Okay, so here we have saved the one document. Similarly, here if you have multiple records, you can copy and paste that. Okay, so let me show you. Click on new document, click on save. It's here already. So okay, so here you can see that our MongoDB is currently working fine, but here once we have this, okay, so we will also require to implement, if we have to implement the, we have to implement multiple things to be making the production ready. Okay, so this is also not till now production ready, because when here I am saying like here kubectl get pod, okay, means we have selected somewhere minimum undesired state is 2. Okay, so Let me show you the HPA. So you already seen how HPA was working. Okay, but with the HPA we have to also take care of the sticky session based on our applications characteristics. Okay, so I'm not going to deeper in that area. So here let me try to increase the load, and I will show you how HPA is automatically scaling, okay, behind the scene regardless of these sessions. Okay, because here we have to do the multiple application specific configuration to maintain the sessions, okay, correctly, so that all the correct route, okay, and multiple things, okay, so that these all are the things will be we have to do with the coordination of our application streams. Okay, so based on our applications we have to maintain those things. Okay, so let me ls here kubectl apply -f StatefulSets HPA.ml. Okay, so now HPA is created. So let me increase the load on that. So here I will basically use the Apache Bench marking tool to increase the load. Okay, so what is basically do? It's basically create a temporary Kubernetes pod that is Apache branch. Okay, and image here we will use HTTP offline image, and here we'll send the 50,000 HTTP request on this URL. Okay, with the 100 of the parallel users. Okay, so let's come here and paste this to trigger the HPA auto scaling kubectl get pods. Okay, so here currently 2 are running. Apache Bench is also running, so we will see live scaling. Okay, so always remember that we have to do the others multiple application specific configuration, like to maintain the sessions, to maintain the data consistency, and to maintain the security like things. Okay, that will be the more production and application oriented. Okay, so wait. Okay, so here you can see that it's automatically scaled to from 2 Mongo Express to the extra 3 is created. Okay, so let me show you. Okay, so here you can see that. Okay, so it's scaled to 0 to 4. It means currently we have maximum 5 replicas of Mongo Express. Okay, that we have specified in our deployment of the Mongo Express. Okay, so now Apache Bench has read in either state. Okay, so based on the CPU, and similarly we can create the stress based on the memory. So here let me remove that. So here let me delete the Apache Bench kubectl delete pod name is Apache Bench. Okay, so let me check the utilization here. On the Mongo Express 0, first of all, sorry, it has auto cooling period of 5 minutes. Okay, so after that it will basically start scale down. Okay, so let me, we can either what we can do, it will take some times to so we will manually, we can just scale it down. So we certificate StatefulSet kubectl scale StatefulSet. We have to scale, let's suppose we want to scale, like our load is down, we can manually scale it down. Although we have implemented HPA, that will we have also spent the cooldown period, then when the period will occur, then it will automatically just scale down. Okay, but here right now we want to manually scale down because here we are present. So here we want to scale down to Mongo Express StatefulSet. Okay, hyphen replica. Here we can specify the replica is equal to 3 or anyone, like here I have specified currently replica is equal to 3, so it's it will immediately in effect. Okay, so right now we can see that we have only 3 replica. Okay, so in the same manner we can also scale it down to 0 or 1. Okay, so here you can see that right now we have only 1 replica running here. Okay, so in the same manner here we can also check, like after scaling down, is our database is working fine or not. So here you can see that our DB is currently in fine state. Okay, so here we can create collections and we can also create the new documents here, although we have to here implement the multiple other configuration to make it consistent, to make its session work 100% fine. Okay, so that's it for today video. In today's video we have seen that how we can just create the all these resources, like how we can create a StatefulSet, how we can create the deployments, how we can create service node port or headless services with cluster IP too. And here we have not created cluster IP directly, but node port eventually uses the cluster IP behind the scene. Okay, so we are already seeing that in our lab, and here we also see that how we can create the PVC and storage class and how we can claim that. Okay, here we have seen how HPA we can increase based on CPU or memory metrics. Okay, and also we have also specified the behavior for like scale down or scale up behavior, how we can define that. So all things we have checked in action. Okay, so that's it for this video. We will go into more advanced options in further videos. Okay, so stay tuned with the Tech Easy. Thanks for watching the video.